This is the second video of a two-series videos that describes point cloud handling enhancements in Imagine 2016. In the first video, we looked at enhancements focused on point cloud visualization aspects. In this video, we'll be looking at point cloud operators. Beginning in the 2014 release, Imagine Spatial Modeler has several point cloud operators including merging, subsetting, deleting pointers, and RGB encoding, and so on. The architecture underlying these operators basically uses the existing point cloud editing capabilities. The problem with that is that now the operators are global operators, which means these operators work on the full extent of the point cloud data, and the result from each operator is often persisted as a temporary file and passed as an input to the next operator in the chain. And this goes against the philosophy of the spatial modeler environment. What we want is for our operators to be streaming operators, which means we want them to process on a subset of the available upstream data as soon as it becomes available. In this release, we have rewritten the point cloud operators to be streaming operators. And as part of this exercise, we also have enhanced some of the point cloud operators. Let's look at a few of them. To make it easier to compare the operators in Imagine 2016 and 2015, I have launched both of them side by side. 2016 is on the left, 2015 is on the right. As you can see from the names of the operators, the names have slightly changed between 2015 and 2016, but I think it's still intuitive enough to recognize which operator has become what. Okay, let's take a look at a few of them. I'll start with point cloud encode. This is what used to be called RGB encode previously, and its purpose is to add RGB information from a raster into a point cloud. Now, in 2016, with the addition of LAS version 1.4, we can now write near-infrared information to a point cloud. So, we have added that capability to this operator and changed the name from RGB encode to a more generic name and called it point cloud encode. Next, let's look at point cloud measure volume. In 2015, we have two operators that dealt with volume, point cloud volume and point cloud volume differences. In 2016, we have merged the functionality of those two operators and made one operator that can do a volume measure and volume difference. Okay, now let's take a look at point cloud to raster operator. This operator takes a point cloud, and in previous version it generates three outputs simultaneously. The outputs are a DEM, a thematic image, which is based on class information, and an RGB image if the point cloud has a color information. In this release, we have changed this and made the output to be mutually exclusive. We have introduced a new port called raster type, where you specify which output you want. You can, of course, use this operator multiple times in a model to generate the different outputs. These are the major improvements. The other operators are more or less the same in terms of functionality. Let's now take a look at two example models that are mainly constructed using point cloud operators. Okay. Alright. Now let's look at sample models that use point cloud operators. I have two models loaded in my shoebox. Let me load the first one. This model takes a point cloud data and generates contours, relief, slope, and shading. how it does that is it basically looks into a folder to create a list of point cloud data using the iterator, and feeds that list to the merge operator. The merge operator merges the point cloud data into one point cloud file, passes it to the point cloud to raster operator. As we all know, the point cloud to raster operator generates a raster which has gaps, and I have used a convolution operator to fill the gaps from the neighborhood pixels. And once I have done that, then we just feed it to the generate contour operator, the relief operator, the slope operator, and the shading operator to generate outputs. I have also elected to output the raster data that has holes and the one that doesn't have holes, just for comparison purposes. Another application area where point clouds are heavily used is in shoreline monitoring. Let me clear this model and the shoreline monitoring model. This model takes 2 point cloud inputs and generates a difference image and a shapefile that shows areas that have been eroded. As an input, I have used the point cloud data from the New Jersey area before one before Hurricane Sandy and another one after Hurricane Sandy, and basically take it through the steps, rasterize it, rasterize the one after Hurricane Sandy, and by subtracting those two images we can get a difference image that shows us where there are changes. Another thing that we can do is take the one before the hurricane and the one after the hurricane and use the data before the hurricane as a reference point cloud data, and then compute a volume difference, and areas where you need a fill are basically areas that have been eroded, and that way you can identify erosion prone areas, but in this case you can identify areas that are affected by Hurricane Sandy. Alright, so this concludes the enhancements we did in this release